Good afternoon, everyone, and thank you for joining us for today's online talk, using a combination of Confluent Cloud and Kafka tooling on your laptop for solution prototyping and development. My name is Joanna Grimmond, and I'm a marketing manager here at Confluent. And speaking today, we have Nick Walker of Confluent partner Synthesis. Synthesis is a highly specialized software and systems developer. They offer consulting, integration services, and technology-based product solutions to banking, financial services, retail, and healthcare sectors in South Africa and other emerging markets. The team at Synthesis have in-depth knowledge of leveraging Confluent Platform and Confluent Cloud to build scalable data solutions and accelerate the real-time data streaming journey of their customers. And a great example of this is the work they did with Discovery Vitality, where they worked together to rebuild the underlying Kubernetes container platforms for optimal performance. And in just 4 months, the team rolled out multiple environments across Ireland, Frankfurt, Korea, and Japan. So before I hand you over to Nick, I'm going to launch a quick poll, and this will just give people who are still joining a moment to get set up. So if you can please take a second and answer that. Okay, that's fantastic. Thank you to everybody who answered that poll. With that, let me just tell you, if you do have any questions that you would like Nick to answer, please pose them in the questions box in your GoToWebinar control panel. We will also be sending out the recording of this presentation later on today. So with that, now let me hand you over to Nick, our speaker for today. Over to you, Nick.
Thank you. Thank you, Jenna, for helping so much in organizing this, and also thanking Confluent for sort of arranging this stuff and gives us the opportunity to talk. My name is Nick Walker, and obviously my name is really a solution architect at Synthesis, and I've been involved in data and data pipelines and databases for many, many years. My background really is more involved with manufacturing data and sort of like the days before IoT, getting data from or sensor data and getting sort of information from that and historizing that data to sort of basically try to make manufacturing more efficient. I saw Kafka many years ago. I got very excited about it, largely because of the fact that it's like a streaming environment and it allows you to integrate it with IoT. So I had this sort of background of Kafka and IoT and manufacturing. Synthesis Software Technologies basically is like a company which basically deals with strategic projects and does software products and it obviously deals with common challenges. It's been going for 20 years and it's got very exposed to banking and fintech companies, and it is obviously a sort of premier AWS advanced consulting partner. And it is obviously it's got history of also been involved with the security beforehand. We are also a Confluent consulting partner, and basically we have some couple of clients associated with that. I mean, when we first started, we got into with Vitality, and they obviously have Kafka involved there, which is really in self-managed mode, and it's obviously deployed in numerous environments, different regions throughout the world. It's quite an exciting story. It's obviously more like a DevOps operation, but quite an exciting story. There's also a lot of the banks are using Confluent. There's a couple of banks who have got Confluent licenses. And then we also have other partners, Cloudflare, HashiCorp, VMware entails. Okay, it's sort of like intended audience here. I mean, I'm really focused more on sort of solution developers, really, because I'm just relating a story which we went through recently. So it's like a a post-mortem of what you can do to change and make things better. I'm covering a couple of things. Obviously, a quick info into Kafka. I mean, I guess most of you guys are very well know Kafka. I'm just going to do a quick one slide over it. And I'm going to talk a little bit about Confluent Cloud and also the Confluent Docker images, which we can obviously run in various different places on your laptop or in Kubernetes and whatever. And I'm also going to talk a fair amount about Connect. From the streaming point of view, we're obviously dealing with KSQL and sort of the secondary phase, which is KSQL DB. Largely because it's quite important to use it as a way to describe streaming. Kafka 101, quick intro. Really, it's all about the log. The immutable log is really the essence of Kafka. It's all about the ability to append records to the end of the log and basically not change them thereon. There's obviously ways to get information into the log. It's from producers, which can be sort of like an API, really. And then consumers basically try and consume some information from the log. It's also an API level. There's a secondary level, which is called doc connectors, and this kind of connectors they interface with different external systems, and it's like a big thriving area. There's a Confluent hub in Confluent, which has got a whole bunch of, obviously commercial ones, and obviously sort of like open source ones, and it's a great area. And almost any third part or like an external system almost has got like a connector out there, which can interact with the log. There's a section below which is called essentially the streaming engines, and that's really a couple of ways of doing that. You can obviously provide streaming functionality, obviously processing data is flowing through this log, and doing it by code in terms of an API in Java, or else you can use KSQL or KSQL DB to try to make it a little more simpler for the average person to construct those kind of like those streaming entities in using SQL. Okay. Creating Kafka solutions to clients. This is really an interesting story. Creating solutions for clients is quite common, and as a company, we do it a lot. Most clients, security is a major concern, and particularly in fintech and banking sector, is paramount. Onboarding with these clients can take time. There's security checking and there's vetting. There's provision of the client laptop for the person to use. Enabling email and getting suitable amps what they use loaded up and to get familiar with them. Provisioning of commuting resources can be tricky as well. Obviously, there's existing stuff, and you have to be quite often end up dealing with sort of like on-prem situations, and also providing sort of resources sometimes can't happen quickly. So you have these issues. Getting access to relevant data sources can be tricky. So you have to, often when you create a solution with Kafka, you need to deal with sort of these external sources, and they're usually our databases, and they're probably legacy or key data sources. We have to be able to get accounts to look at them, and also try and establish the schemas and the flow rates, and lots of stuff has to be get involved quite quickly. So in reality check, you are as a team are ready to go, and you've got all the tools, but many days later, the onboarding is very much just one person with a small hammer and a screwdriver. Really don't have all your capability because you really have a different environment. So developing with the client infrastructure can be tedious. You have to create topics, you have ACLs because this is now secure environments, and just talking about a client where you have like a self-managed cluster which is looked after by some service personnel or processes. If you want to create schemas and deal with other these things, you often have to interact with service personnel or processes, and that can be tricky. So in developing a streaming solution, a topology, it's really a repetitive task. You have a circle here where you have you create topics and you load some sample data from maybe some, CSV initially, or maybe from a data generator, or possibly about the real data. And then you have a look at it, and there's some issues, and then you say, okay, let's clear them out, clear the topics. Then you refine the schemas, and you refine your streaming code, and then you have to recreate the topics. So this is like a cycle, and if you deal with service personnel processes, it can be quite slow. So the other issue you do have is you get to know some good tools to facilitate your productivity. Things like Kafka Cat and Zoe and Data Gen, which is sort of data generative tools, and also visualization UI aids, for example, like lenses or land loop UI components are really handy to have. And if you get to know them well, you can be quite efficient with them. And if they're not there, it's like a bit of a nightmare. So how can you speed up this process, to upshift development pace? And I'm sort of telling a story of setting up an alternative deployment, particularly initially, because it's quite nice to have something which is basically similar to client in terms of it's got security, and it has all your favorite tools and all the stuff that makes you more efficient, and it's shareable. The proposal really is to shift the Kafka cluster to Confluent Cloud. To say, okay, free up memory resources from your laptop by by removing basically the cluster, the Kafka image and the Zookeeper image away, and allows you to put more tool information on your laptop. The solution really is to say, okay, let's go to a Confluent Cloud with a sort of low-level flavor of its offering, and use Docker-based Kafka tooling running on your laptop. So here's the story from Pictorially. So on your dev machine, so your laptop, and this could also not necessarily be a laptop, it could be in the cloud, but initially it's quite nice to have it on a laptop, which you can be mobile. So there are Confluent images which are very useful to have, and there's obviously ones from Schema Registry, Connect, KSQL DBs, and the server side, the client side, and Confluent Control Center is also available, and those are also kind of available, and you can use them. There's also some handy things you want to do to make the environment a little bit closer to the client. So you might want to have certain databases that they've got and certain versions of databases, and you might say you use maybe Elasticsearch or Snowflake or whatever others the client has got. And there's also quite nice handy tools to make you efficient, things like Kafka Cat and Zoe. Sometimes you wouldn't use these maybe in a Docker, maybe sort of on a command line in your laptop. And there's also, if you're in a streaming environment, you can obviously use KSQL, but if you want to use code, you will then obviously create your own images by compiling with Maven or whatever, and creating your Java code, which you are going to deploy. So those also need to be available on your laptop. Then obviously this talks over to Confluent Cloud, obviously. My demo I'm really talking about today is based on like a particular Confluent example. It used to be actually in the Confluent examples repo, but it's recently moved out into something called CP All-in-One, and it's a variant of that called All-in-One with one in the cloud. So it really saying, okay, this is a situation where a whole bunch of stuff is running in a Confluent in Docker-compose on your laptop and talking out to Confluent Cloud. Also, you need to, this is obviously generic stuff. It's quite nice to start, but you're also going to need to add extra bits and pieces in there. So you're going to go to the YAML file. You're going to add all sorts of bits and pieces like connectors, tools, and stuff to make it more efficient. So the process of stream topology development is really an incremental exercise. You start off with source connectors, and you have this whole sort of like example story here of S's and T's, where really from my point of view, it's like S for streams and T for tables, which are core elements of nodes within the streaming topology. And you tend to have to go through this exercise of building this out serially, in an incremental way. And eventually at the end, you'll end up with maybe a stream at the end or tables at the end, which you have to feed out into sync connectors, which feed out to external systems. To start off, we tend to start off from the left-hand side. You tend to create your source connectors. And if you set up your environment and your client, you get some certain information about what sort of data sources they have, or maybe some example data, including CSV files or particular databases, or potentially later on data general tools. You can go and create connectors in various ways. You know, this is the modern way. We could say, okay, I could use KSQLDB to create a source connector via a syntax associated with this particular Postgres database. So that's one way of doing it, and that's really why, because it encompasses the concept of the Connect REST API. But you could also use it an old way, the sort of way of saying, okay, create a connect. Create some JSON code to define it in terms of properties and get it up and running. Then sometimes you could also might also at this point go to the end as well. So okay, my sync connectors, I might actually also define this point, because you're saying, okay, I know I'm going to go to Elastic. We sort of know what the output should look like. So you can say, okay, I sort of know my output topic or output stream has to have this sort of feature. And you can almost like mock it up and define the sync connectors, for example, Elasticsearch, or for Snowflake, or an external system like a modeling tool or whatever. Then the section in between here, we have to start from the left, really. So it's like a development time incremental process. You start off with the syncs, and you sort of refine these things and, you know, augment them and provide more information, and it makes a more realistic sort of like pipeline from the source to the sinks. And here's an example one, defined in KSQL, where you say, can we create a new stream, which is based on a new topic, and it's using fields from an existing stream, the one before it, and basically use the syntax of saying emit changes, which basically means it's like a push query. And KSQLDB has two sorts of ways of dealing with data. It's a push way, where it's like a continual flow of data. So you execute the SQL statement, and it carries on going and waits until the next record comes through. And then obviously the pull stuff is more like a query an existing sort of like source, much like a normal database. So this is really like a left to right exercise, and it's like very iterative. Initially you might just use CSV files because they're quite small, and you could say I can pinpoint a small amount, do the sort of necessary sort of like it looks a bit like this schema of this client's database, but just a small amount of data, and you can use it as a way to increment. So you build up this whole sort of like topology over time. Confluent Cloud, it really is. Confluent Cloud is really a fully managed cloud-native event streaming platform powered by Apache Kafka. It comes in 3 flavors. The basic one is very simple. It's on a single zone, and it's really early stage development suitable, and there's no base price or no fixed charges. So it scales down to 0 if you're not using it. The next one is like standard, which is like a multi-zone one, and it has like a certain SLA provided, 99.95, and it has like a base price of $1.50 per hour while you're using it. And then there's obviously the sort of more dedicated one, which is more associated with production environments. So if you had to really, if I was say a client, I'd say I want to move this to Confluent Cloud, you'd obviously have like a dedicated system. Basic and standard clusters are quite useful for development in terms of they've got, they're kind of cheap, and they also are all the sort of requirements you really want. It's got 4 components here. You've got services, you've got like single AC clusters for basic, whereas the standard has got multi-clusters. It has an upside SLA in the standard level, and you've got obviously from a scale point of view, you've got a small amount of throughput, but fine for development. You don't have to drive lots of data in a development environment, particularly in the early days. You've got a storage limit of 5 terabytes, is a fair amount, no problem with that, and it's got a partition limit of 2048 partitions. And it also has auto data balancing. The managed components you have is schema registry and KSQL and connectors. This is all about what's actually available at the cloud level. We're not really going to do that so much with our situation because we're offloading our stuff is more to a laptop. But in reality, if you deploy in a cloud environment, it's quite nice to have the stuff in a sort of managed components in the cloud. It is secure, which is great. So you've got security at rest, and you've got encryption in transit, and you have Kafka ACLs defined, and you can obviously deal with them, and it supports basically SAML SSO. Why is it so appealing for development and prototyping? It's quite easy to set up and tear down clusters. It's very, very easy. And you can do it in two ways. You can do it by the Confluent Cloud portal, sort of by UI, or by a CLI. And we're going to deal with both of those in terms of the demo. It got security baked in, so it's a bit more closer to the client's environment, because what you tend to do, if you operate everything on your laptop completely, you end up in a very much non-secure situation. Your code is not really like dealing with the parameters for security. So it's missing a bit. And in reality, there's pretty minimal cost in using it if you are not putting too much data in and out. So early stages of development, this is very appealing. From basic, it's $0 to compute, and standard's $1.50. Data in is a little bit more expensive than the data in basic compared to standard, but it's still, in gigabytes, it's a lot. I mean, typically you don't use gigabytes. If you're doing like CSV and you're just using a couple of kilobytes, you don't spend money there. And data out also is quite small. And data stores in terms of gigabytes retained is also relatively small. So, if you do I've done this a couple of times. If you do this, you don't actually spend too much, money. It's like cents to do some quick development. Tooling on laptop. So, there's various images you want to put in there. Confluent's got Docker images which are running in Docker-compose, and these are obviously got different versions. And you also want to add, functionality associated with the DPs and stuff which the client uses. I mean, things like databases. Often you'll see in banking, Fintech, you have Oracle and MS SQL and MySQL and those sort of things. You need to have those. And obviously that's all based on JDBC connectors, all those other sources. Elasticsearch is very common as a sort of sink, and also external systems like Snowflake or modeling systems are also really quite important to use. And there's also third-party tools and visualizers which are quite useful for development efficiency. I think Landoop has got some very nice UI components for looking at controlling or setting up connectors and schema registry and stuff like that. And also, maybe the client doesn't actually have C3, so they might have their own way of dealing with monitoring and configuration. So you also might want to use that. All right, there's two demo sections to the demo. I'm going to basically deal initially with like a live period section, and also the next one is basically a pre-recorded section. Give me a second. Sorry. If you want to go to Confluent Cloud, you obviously just Confluent Cloud, browser, and I'm going to Cloud. Sorry, I'm in the wrong place. Go, give me a second. I've done the wrong place. Give me a second. Okay, so if you come to Confluent Cloud, you have to come in with you have to log in and obviously create your own story. If you haven't set up yet, you obviously go to here and you say, okay, I'm going to sign up. And this is obviously ask for information about your particular stuff and whatever. And you also obviously will have to provide a credit card, but it's not really a big issue in terms of development costs. Okay, so I'm assuming you've done this. So I'm going to go back, and if I go back to my previous screen, I'm going to just try to log in completely. So I'm going to go with my particular email address, my password, and I come in here. And okay, so I have a particular cluster here. And in reality, there's lots of stories about this. I'm going to deal a little bit more in terms of the CLI side, but you can define cluster and it has a particular style. So if I go into this particular cluster, I've got information about it, and I can go to, for example, topics on it, and I can drill in and configure things quite easily here. So I can configure cluster settings, and I can obviously, edit settings, for example, the name and, what type it is and things associated with it. So there's obviously, you can create clusters in different cloud providers. So, in this one, I'm set it up in AWS. It can also be done in Google and obviously Azure. And you also have to, during this process, you have to set up API keys, which are keys you use to talk to this cluster from the client side. So if you're coming from your laptop, you need to have these things defined. There's obviously a story about, you can obviously go and create topics. I've got a couple of topics here, but if you want to go and create a topic, it's a very easy process here. I can say test topic, and you can go with defaults, which is 6 partitions, or you can customize these settings and you say, okay, I want, attention type and various stuff you can configure. So there's not much information about that. So it's very easy for me just to save this topic straight away. So it's there. So I come back to it, it's there. Another section here, it's quite worthwhile if you get into this thing, is to set up the client-side configuration. At the bottom here, there's a thing called Tools and Client Configuration. If I look at that, this is a story about how to install the CLI functionality on your laptop. So it's an important thing to do, because with this, you can obviously use your ability you can use C-Cloud to go as a sort of client in a terminal against cloud. So there's a whole sequence of stuff to follow through. It works pretty well. I'm going to show you how you do that in the next phase. All right. So at this stage, I've only got one cluster. This is a very simple layout. So I'm going to think this is enough. I'm going to hand this stuff back to Joanna to play the pre-recorded demo. This is the section of the demo. I've pre-recorded it because I'm dealing with security aspects associated with Confluent Cloud. I'm creating API keys and secrets which I have to flush out before I show it. This terminal window is really on my laptop, and the first command I'm going to execute is Docker PS, which shows me what images are running in Docker from my compose up command. And I've got 2 database images running, a Postgres one and an Oracle one. I've got a schema registry for Kafka support, and I've got a Connect image which has got support for Oracle with a specific JDBC driver. And I've got 2 KSQL databases, one for the server and one for the client. That's really providing my sort of streaming support functionality. Okay, I'm changing my focus now to dealing with Confluent Cloud. To talk to Confluent Cloud from a laptop, you have to have a module, a CLI module called C-Cloud. And the first thing you're going to do is log in. Pretty straightforward. It's going to require my email address, which I'll put in, and then also my password. Okay, so the environment is basically responded saying we've got like a default environment called it's got a name, it's really the default one. That's when created from your initial login. You can obviously list what environments you've got. So I can list them, and there's only one. And they're basically areas. For example, you call them things like dev or QA or test or possibly production for a particular project. So what I'm going to do now, I'm going to create a new one for this exercise. And I'm going to call it demo, Nick, and it'll come back. And obviously, I can obviously list them again, and it should be 2 now. Try it again. Okay, there are 2. So I've got here my default one. I've got demo image, demo Nick. And now I want to make sure I'm going to basically use that particular environment currently. So I'm going to say, okay, I'm going to set my focus to demo Nick by providing the code. And I'm sitting there in, right. So there's obviously no clusters in here. You can obviously create any clusters, but at the moment there's nothing. So the first thing I'm going to do is create a cluster. And that's a pretty straightforward command. To create Kafka cluster, you have to provide 3 parameters. Obviously the name and the cloud provider could be AWS or Google or Azure, and some particular region specification. And this is pretty quick. Any Kafka administrator, this might bring tears to your eyes, how fast this happens. Typically, it's to do in like a self-managed situation would take plenty work, including, Terraform scripts, providing instances, and obviously, Ansible scripts to get us all right. It's obviously created like a basic style demo cluster, and it's also provided 2 endpoints for talking to the cluster. So the cluster is there, and we obviously have to use it. So I'm going to set focus to it. So I'm going to say, okay, let's use this particular cluster. I'm going to say, okay, use, and I'm going to specify its code. And I'm now focused on this particular cluster. So the next thing you're going to do is you obviously provide an API key for dealing with talking to this cluster. So if I can create an API key with a particular name, for example, description, and it also has to specify the particular cluster code. So I'm going to also substitute that. And now I've got like a sort of essentially an API key to talk to this cluster. So from our side, you'd have to specify this key. I need to also set it. So, I have to say, all right, I have to use this particular key for this particular cluster, so linking it. So if I do that, so I have the cluster code, which is this one. And I also have to have the API key, which is provided there. And I'm basically setting the API key for this cluster. So I've linked these 2 things. So the cool thing you would like to do at this stage is just create a topic. That's a pretty easy exercise. I'm creating a topic called COVID-19 data. And the first thing you're probably going to do is putting some dummy data into this. So I'm going to do that. So I'm creating, okay, is it created? So let's do a produce. I'm going to use a tool called produce. And I'm just going to put some pretty basic data into this producer. It's obviously started the producer because it was just started. Do 5 and a Control C. And that stopped. And just to make sure we're doing the right sort of stuff, let's see if we can get the producer to work. If I do that, and I'm basically consuming from this topic with a -b, which means I'm actually going to do it from beginning because you obviously did the production before executed this, so I should be able to get some data from this. And there we are. And that is a super quick story of how you set up stuff against Confluent Cloud from the command line. And it's kind of very simple. It's also other areas we can deal. You can obviously create like service accounts and create ACLs and lots of stuff using the same story. Okay, I'm limited in time, so I'm stopping this demo. Thank you very much. Okay, did we see my screen?
Yes, we can see your screen.
Okay, right. Okay, so now that was a quick demo. It's obviously a lot more stuff associated with that, and then I think it's another sort of potentially another potential story or presentation about to deal with the sort of the KSQL stuff associated with it. But in reality, I'm basically going to cover the sort of like the way I'm going to work here. So if you were in a client and you land up in the situation on the left-hand side, the initial data gatherings mode on the left-hand side, you will go in there and you can obviously usually get hold of some data, not even from initial meetings and whatever, of what's available and what database is there, and maybe some sample data, which has been cleaned a little bit possibly. And this is a good time to basically try and create up your development environment and move it into Confluent Cloud. So what I've said in terms of my laptop, so you do like in a way like a branch, and you basically at least you can start to do some stuff in terms of defining the connectors, and also potentially even doing some of the streaming topology development, because essentially in the early development stage, those red lights mean you're really not that capable because you're not onboarded in time. So there's a sort of period there which is like a quiet time, or which is wasted time. So you mentioned a situation of actually having a sort of platform where you can actually do some work and develop your topology quite quickly. You know, you don't have to deal with sort of the constraints of the client's cluster, and also you can obviously sort of build up the sort of the components which are required. Then towards the middle development, it's quite nice to sort of like bring that stuff back into the client's cluster, and you know, maybe a couple of other iterations of merging as you go through the middle deployment phases. And then towards the end, you kind of will no longer actually really use the sort of like the development environment anymore, as it's really like sort of really just like it's all been done in a situation where it's very close to pre-production. So this is really sort of like the agenda or the plan I'm suggesting. If you want to move between Confluent Cloud and Kafka Cluster environments, there's a couple of changes. You know, if you look at the left-hand side, I've got a particular connect bit of code, which is really it's Docker connect data YAML, which basically defines a couple of things. For example, the group ID, you know, the bootstrap servers, which is basically an URL, and security associated with Docker, with the Confluent Cloud, which is done in a certain way. It's obviously it's SSL. But if you want to move it to your own cluster, you have to. Sometimes it could also be in a Docker, but probably not likely. But if it in a sort of like a self-managed situation, you might have like a situation you have traditional connect properties. You know, for example, on the right-hand side. So you have to translate those things from one side to the other, but not complex. Security can change a little bit. Certainly, the security in banking and in fintech companies would use more sort of like certificates or trust store information, obviously seen on the right-hand side. So you have to just plug and play that stuff in there, but not complex story to change things from one side to the other side. This is obviously connect. There's a couple of areas we have to change. Maybe KSQLDB as a configuration stuff. Any of the components have some sort of configuration which you have to try translate, but not a complex story. All right. In terms of example code resources, there's one very good one from Confluent, which is called examples. In fact, this one I'm using was actually from that initially, and it covers a lot of stuff. So that is a great source of information. There's obviously cloud examples. There's one called Benedict Cloud, which is great. It's done by Tim Berglund, and it's like a story about more or less what I showed, but going much more deeper in terms of working with the Confluent Cloud CLI tool. And it does, it creates clusters and it obviously tears them down. And then obviously the all-in-one cloud, which is the one I've used, is also there, and it's obviously now in a separate repo at the moment. As a developer of Kafka, there's like recently been added a developer Confluent kind of area, which is really handy. It's got resources for podcasts, blogs, and videos, and also Kafka tutorials, demos for getting started, and there's also a great section for community section. Then also quite handy to have to get you going quickly with Confluent Cloud is as like a quick start, which is like very straightforward story to get in and set up your account and do more or less what I did initially. Then, if you want extra information, there's a Slack channel in Confluent, which is very, very handy. It's got different sections for different areas, for example, Kubernetes, connectors, and information is pretty worthwhile to follow. There are some very good people associated. I mean, there's more information about in terms of setting up the KSQLDB and that sort of and set up connectors. Robin Moffat from Confluent has got some amazing videos. He's got his own YouTube channel, and that's also very handy to have. Okay, that is my close. I Many thank you, very many thanks. And I must basically ask for a call to action. Contact Excercise to leverage our Kafka and Confluent platform and Confluent Cloud capabilities. And also anybody who wants to is more interested in to further explore this demo to get more deeper into it. Obviously, there's a lot more information in there which I couldn't really do in the time frame, but there's a fair amount of information which I can share. And certainly follow us on social media. Thank you very much.
Okay, thank you, Nick. So now we have some questions for you. The first comes from Daly, who asks, do you have to go for dedicated with production environments on Confluent Cloud? Is the standard not sufficient?
I think it depends on your particular use case. I mean, I think for example, if you had to say go to Vitality, which is a big company, you wouldn't go and put it on standard. You'd put it on like a real serious dedicated requirement, because of the requirements you have you have knowledge of the data flow. You need to know where your spikes are. That has to be in a way has to be dedicated, because it has to be resourced correctly. If you are smaller, I guess you could do some stuff. And it's interesting story there. A lot of the not all of the Confluent Cloud is supported by the Kubernetes operator, but I mean, certainly the basic and the standard stuff is also driven by essentially like a Kubernetes environment with their environment. But I think the bigger sites they have more sort of SLA requirements. And I think, depending on your scenario, you might want to go that route.
Okay, thank you. And then Daly asks another question, which is there any third-party GUI tool that you'd recommend for administering Kafka locally or connecting to brokers remotely?
There's a couple of sites, of tools. There's obviously the ones that came out initially from LinkedIn. The names escape me. There's definitely ones from LinkedIn. There's also one called Kafka HQ, and more recently, and there's definitely ones out there. And some of them are actually quite good in terms of they can deal with dealing with schema registry, which is important, and obviously connected, because you want to cover all those areas. Yes, there definitely are some good tools.
Fantastic, thank you. And then the final question, which is from Angela, and she says, I see from the Confluent blog that Audi use Confluent and Kafka for their connected cars project. So do you recommend Kafka in general for IoT and sensor data projects?
I don't. I think it's an interesting question to answer. There are lots of solutions to IoT, and there's obviously one more specific to IoT. But I think in terms of a scaled environment, Kafka can deliver, because in a way Kafka is highly available, fault tolerant, and can be scaled out horizontally seriously. So in a way it's quite handy. Audi is interesting because they produce a lot of data. They've got how many cars, you can imagine how many cars there are out there, and each particular car can produce 800 different metrics. And you just multiply that out, it becomes a huge amount of data. So I think it's important in large scale environments, it's appealing. If you want to deal with smaller environments, possibly which are focused in more directly maybe to manufacturing, there are other solutions. There's stuff from Eclipse, and there's obviously stuff from AWS and Microsoft as well there.
Okay, wonderful. Thank you so much. So that's all our questions for today. Thank you to everyone who attended, and thank you for speaking, Nick. And with that, we are complete.